Okay, in this session, we're going to be continuing with our thinking about division. I'm going back to the chart to reference one more time. The last problem that we just looked at, because we actually knew the total and we actually were sharing that total equally or just dealing out the number of groups were known. So remember how we had 24 things and we knew that there were 3 groups? So we were just actually partitioning out 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, until we hit 24. And then we were able to see that there were 8 in each group. This time, we're going to be looking at a different type of division problem called measurement. Again, it is just separating. You have a whole and you're separating that whole. The first time we took the whole, we separated it because we knew that our divisor was the number of groups. This time it says partitioning the same number in each group. So this time we have a total, but our divisor is not the number of groups, but the number in each group. You know the number in each group, but you're looking for the number of groups. So let's see how a measurement division problem, and one of the things that helps me to kind of keep measurement in my head, it's like when you're measuring something, you actually know the length of it, or I know how much I weigh, or I know the measurement of it. So when I think about the difference between partitioning and measurement, my brain always goes to partitioning is partitioning out, which means I know the group, but measurement means I already know my number. I know this length, and I'm just repeating that length over and over and over. So let's take a look at this problem. And again, I'm in the 3-4 bar model activity cards. The school librarian received new books. If she puts the books on each shelf, how many shelves would be used? Okay, so what do we know? We know that the school librarian received some books. Don't have any idea how many, but we just know that she all of a sudden has this box of books maybe. She puts some books on each shelf. So here's what we know. She's got some books that she received, and she puts some books on each shelf. How many shelves would she use or would be used? When you think about this problem, you've got books and books, but we're trying to find out how many shelves. So the next thing we would move to is, well, what do we need to know again? Well, we want to know how many shelves she used. So ask the kids to turn to their partners and kind of explain to each other, what is this problem even about? So you're going to get the kids thinking about, well, she's got this box of books, and then she puts the same number of books on a shelf. And then she takes that same number again and puts them on another shelf. And a same number again and she puts them on another shelf. So what we want to know is, how many shelves is she going to use to take every one of the books that perhaps she has in this box? So when all the books are gone from the box and they're all put on the shelf, that's where she notices that she only wanted a certain amount on every one of those shelves. And in this particular problem, because it's just written this way, it's going to come out even. So we would think about, how would we then model this problem? In your teacher guide, it tells you, well, let's let the purple represent the total number of books. So I'm going to write this up here, the total number of books. In the open list number problem, do we have any idea what the total number of books were? Nope. But what we know is that she used the same amount on the first shelf and the same amount on the second shelf and the third and the fourth until all of those books were gone. In your teacher guide, it tells you just to use the reds to represent the number on each shelf. So basically, sometimes I'm going to show you, this is how I model it. This is what I know. I've got some books, and this is going to be the number on each shelf. And at this point, I don't have any idea how many times that this is going to be repeated. What is that dependent upon? Hopefully your students are going to tell you what's going to depend upon how many books she has in that shelf. I mean, in the box, because what you said was she's got to keep putting those books on shelves until all of these are gone. So this would be a good opportunity to think about what you're doing here. You are taking a total and you are separating these. But this time, what is your divisor? It's going to be the number of books on each shelf. So this time, this bar does not represent the number of groups. It represents how many are in each group. Well, I'm going to move that to the side because there's our initial thinking. The bars helped you think through that this was truly a separating problem. But are we separating this from just that, and that's my answer, or am I doing this as repeated groups? That's how you kind of know the difference between subtraction and division. Well, let's turn on the back side. Same identical problem, but now we have the quantities, which is really going to help us think through this problem, boys and girls. Okay, the school librarian received 72 books. Now, what does that 72 books represent? That represents our total. If she puts 9 books on each shelf, so now I know that that bar represents 9. And that represents the number of books on each shelf. The question says how many shelves would be used. So I want you to think about this. You've got books being divided by books, but your answer is going to be shelves. Okay, and remember this right here is always your total, because you know in division, we already know the total. We're not looking for it. In multiplication, you were looking for the total. Think about addition. You're looking for the total. In subtraction, you already know the total. So those are some good connections that you also want to help kids get that deep understanding about. Another cool thing to think about here is my labels are the same, but I'm looking for something totally different. Go back to your thinking about addition and subtraction. Our labels in addition and subtraction were always the same, but we also were looking for the same thing. In multiplication, your labels were always different, but you were looking for the label that was the same label as the number in the group. In division, you have 2 different types. The previous problem we worked is we had different labels and we were looking for one of them. In measurement, you always will have the same label, but you're looking for something different. So how many times can I repeat the number 9 if we had a total of 72 books? Do you remember originally I told you to think about which one of the division problems was repeated subtraction? Is it this one or was it the partitive? Yes, it's measurement. Measurement is the only division problem that is repeated subtraction. This one, I am taking 72 total, and I could just keep pulling out 9, and just keep going until I had the answer. Now, do you want to do that? The answer is probably no. So what we're going to think about is we have 72, and we are dividing this by 9. And I want to know how many shelves that this is going to be. This is an opportunity to really talk to kids about that connection between multiplication and division. what number times 9 gives you back 72? Well, it's 8. And if you go up here, you've got 1, 2, 3, 4, 5, 6, 7, 8. What I will tell you is when you're modeling these, we have set it up so that the colors will come out even. If these numbers, or as these numbers grow in quantity, really this becomes almost obsolete. You just want the kid to get to this action that I'm taking a total and I'm dividing it by 9, by 9, by 9, by 9. So how many times does 9 go into 72? Or how many times, no, not how many times, but if you had 72 books, how many times would how many groups of 9 would I have? Well, you're going to have 8 groups of 9, because remember, this was the number in each group. So this becomes your groups, and this becomes your total, which is still the same label as the number in each group. See the connection back to multiplication? Groups times the number in the group equals the total, which is the same label as the number in the group.